Hello everyone, this is Algo Conqueror. I hope you have given today's Leetcode contest and I forgot the number. Wait a minute. Today's contest number is 303. I hope you have given the contest. Now let's discuss the solutions. And this is the first question. Pretty easy problem, I think so. We basically use hash set here. Take a minute to read the problem. Given a string S consisting of lowercase English letters, return the first letter to appear twice. A letter A appears twice before another letter B. If the second occurrence of A is before the second occurrence of B, then A appears twice before B. S will contain at least one letter that appears twice. The question is basically stating that whichever the letter which appears twice first, that letter we should return. So let's consider this example. ABCC BAACZ. The first letter which is repeating is C. So we have to return C. And the approach is simple, pretty simple. We use hashing. We go on storing the letters. If the current letter is already in hash set, we'll return that letter. Let's dry run it. So the given string is A B C C B A C Z. So let's consider this as our hash set. First we are here. We check whether this is already in hash set. No, it isn't. So we'll add it to hash set. And then we go here. We'll check whether it is in hash set. No, it's not. So we'll add it to hash set. We'll come to C. C is not in hash set. We'll add it. Now for this C is already in hash set. So this is the one. This C is getting repeated. So we have to return this C. I hope you understood the approach. Let's look at the code once. Code is pretty simple. I have coded it in Java. The approach is same, however. We create a hash set and we iterate the string using a for loop. If the current character is already in the set, then we'll return the character, else we'll add it to the set. And default I return some random character. So this is how we do it, the first problem. Now let's move on to the second problem. The second problem is also based on hashing. So we are given a grid and it consists of numbers, integer grid. A row column pair is considered equal if they contain same elements in the same order. So for this case, let's look at this case. Wait a minute. I took the screenshot of it. Yeah. Here we are given a grid and this row and this column are basically same. So how many should we return, the number of pairs? Or yeah, we have to return the number of pairs such that the row elements and column elements are equal in same order. So for this grid we have 3 to 1. Oh no, this is not the one. Wait a minute. So the repeating elements are not 3 to 1 but 277 and 277. These are repeating. 3 to 1 and here is 312. That's not the one. So how will you approach this problem? My mind is thinking about how about we store 3 to 1 in the form of string. All right. No, we'll store 312, 277 and 167 in the form of strings. 312, 277, 167. These are the column values. And we iterate the grid row wise and check whether the current row is already in the given. This is a set, right? We'll check whether current row is already in the given set. How many times this is not set, this is a map. We'll store the count of each string. Okay, 312 is appearing once, so we'll store it as 312 comma 1 in the map. And 277 is appearing once, we'll store it as count 1. And I'm getting confused. 167 is appearing once and we store it its count as 1. This is the hash map. First we iterate column wise and store them in hash map, their counts, and then we'll iterate row wise and check how many times this string is in the hash map. We'll return that much number of pairs as an integer. I hope you got the approach. So if we iterate this grid row wise, we'll get first string as 3 to 1. Is 3 to 1 in the map? No. So we'll do nothing. And we'll check for 176. Is 176 in the map? No. So we'll move on. And the next string is 277. Is 277 in the map? Yes, it's there. How many times is it there? 1 time. So we'll add 1 to our result. So the result becomes 1. This is the approach. Let's look at the code. So I am maintaining a map of string and an integer. This is basically storing the column wise strings in the map. So I named it as map column. So I'm iterating. M is the number of rows and N is the number of columns. For every column for each column I'm creating a string by iterating and then storing it in the map and incrementing the count. I'm incrementing the count every time I encounter it. This is basically storing strings in map, and then we iterate the grade row wise. So the M and N got interchanged if you clearly observe. So now I create string of each row and check how many times is it in our map. And I'll increment the count of that string in the map to the result. And finally I'll return the result. I hope you got the approach and the coding part. So we'll move on to the next question. This is the implementation question. Take a minute to go through it. Here the question basically is stating that we are given certain foods which are of particular types and with certain ratings. if I try to write this down, a particular food has three attributes: name, type, which is nothing but cuisine, and then rating, right? And here it is stating that in the constructor we have to create these foods, and we can change rating of a particular food by this method, change rating method. What does change rating do? Change rating changes the rating of a particular food. The parameters are new rating and food. And there is another method called highest rated, which is basically the parameter is type cuisine, the type, and we have to return the highest rating of that type, highest rated food of that type. I hope you got the question. I have explained all the three methods, the constructor and the two methods. This is basically the question, and think how to approach this problem. And if you studied priority queues, the idea would have stuck in your mind. So, what are we trying to get using this highest rated method? We are getting the maximum value of a particular type, right? The question is stating that we have to return the maximum value of a cuisine, which tells that each cuisine will have different foods. Each cuisine have different foods with ratings. So for each cuisine we have to maintain a data structure which returns us the maximum value. Which data structure do you think would fit in here? Yeah, you guessed it right. Priority queue. Priority queue or max heap. This will get us the maximum rated food in a particular cuisine. That's okay, but how do you link these for each cuisine? How do you store these data structures? For that purpose, what would you use? Yeah, map. A map would do it. A hash map. For each cuisine as key, we maintain a priority queue as a value. This is basically for the highest rated method. Got it? Now we figured out the third method, highest rated method, how to approach, and how do you handle with this change rating method. Change rating is nothing but you are changing the rating of a particular food. Let's take suppose there is a cuisine X which has foods of different ratings. Let's take 5, 4 and 3. Okay, now if you call the highest rated method, which food will you get? Yeah, the highest one. It will return the 5. But if I change the rating of this food from 5 to 1, uh, how will this data structure be changed? Now in this priority queue, we have values of 1, 4, and 3. Now the highest becomes 4, right? So what we basically have to do is we have to delete this object from the priority queue and add the update the rating of that object and add it back to priority queue. I hope you got the point. I'm repeating it once again. Whichever food you want to change the rating, if let's take this is the first one with rating 5, you have to change it to 1. Then what you will do is you will pop out this object of type food and update its value, update its rating to 1 and add it back to the priority queue so that the order isn't messed up. I hope you understood the problem. If you haven't, I'll walk you through the code so that you can better understand it. So firstly, I have created a class called food which has food name, rating, and type. This is the constructor. I'm basically initializing the members of this class. And I told you about how to store for each cuisine a data structure. We use a map, and this is that map. For each string, we are maintaining a priority queue of food. Okay. And I'll come to this later. And this is the constructor of the class. I'm basically initializing the map and I'm iterating it. N is the size of the array. I'm iterating the array. If the map does not contain the current type, cuisine type, then what will I do? I'll add the current cuisine to the map and add a new priority queue to it. And this is the comparator I used for the priority queue. It was mentioned in the question that firstly we need to check the rating of the food, and then if the ratings are equal, we need to return the lexicographically smaller food. So that's what I have done here. If the ratings are not equal, I'll return the highest rating first. If they are equal, I'll compare the food names. The lexicographically smaller one I'll return, and this is the comparator. And this if is that this in this if we are doing if the map does not contain the current type, I am creating a new priority queue for that type and adding it to map. Now I am creating food object. So I'll tell that, and we basically are using this food map for the purpose. I previously told you that we have to remove this object. Just wait a minute. We have to remove this object from the priority queue. How do you remove this object from the priority queue? Any idea? Priority queue has a method called remove, which takes parameter as an object. If you pass that object, it will remove that object from the priority queue. So what I'm doing is, in the change rating method, if the rating of a particular food has to be changed, what should you do? First, you have to remove that food from the priority queue, right? So for every string, for every food name, I'm storing its object. I'm storing its food object in the food map. That's what I'm doing here. Current is a food object and food sofa is the food name. I'm storing the object of that food name in the food map so that I can get that object here in change rating method. So I am getting in the change rating method, I have food name as a parameter. From that food name, I need to get the food object. Why? Because I have to delete it from the priority queue. I have to remove it from the priority queue. So this food map is for that purpose. For the food name, I am getting the food object from that. So I am getting the object and I am updating the rating of that object using the new rating, and I am removing that object from the priority queue and I am adding back to it so that the relative order doesn't change. Okay, so the priority queue will retain its order, its nature, by removing and adding it back to the priority queue. So what does the highest rated method do? We are given a queue sign and we'll get that priority queue from the map. For each queue sign we stored a priority queue, right? I am getting the priority queue from the map, and after that, if the priority queue is not empty, I am getting the maximum from that priority queue. I'm not removing it, I'm just peeking it. So it does not get removed, the max does not get removed, but it will just return the max. And we need to return a string, right? So this priority queue will return the food object and I'm getting the name from it, food name from it. So this is about the third question. I hope you understood it. Let's move on to the final one. Interesting one. Okay. Take a minute to read this problem. This problem includes around 2 to 3 concepts. Now let's see the fourth problem. What would be the brute force way of doing it? Think of it. The question states that you are given a zero index positive integer array nums and an integer k. A pair is called excellent if both num1 and num2 exist in the nums, and sum of r of num1 and num2 and sum of the number of set bits in num1 or num2 and num1 and num2 is greater than or equal to k. What would be the brute force way of doing it? So let's take an for now don't care about these things. I'll explain to you later. So how do you do it in a brute force way? Brute force. So let's take an array 1 2 3 4 5 and k is equal to, let's say, 4. So how would you do it? You will definitely iterate the array, and for each element you are going to run another loop and find out the or of the two elements and of the two elements, and sum them, sum find the sum of the set bits in that, and check whether the set bits count is greater than or equal to k. And the pseudocode will look like this: int I is equal to 0, I less than n, I plus plus. For each element you are going to run another loop from I plus 1 j plus plus, and what you'll do is you'll find the or of arr of I and arr of j, and you'll find the and of arr of I and arr of j, and count the number of set bits in this or and sum them up and check whether it's greater than or equal to k. This is the brute force, and time complexity of this approach is O of n square. Can we do better? Can we do better? I think so, we can. Because I took some examples here. Let's take this example. Let's consider this number as a and this number as b. And there's a wonderful thing you can notice here. If you OR these two numbers, you'll get this. If you AND these two numbers, you'll get this. And for this, if you OR these two numbers, you'll get this. And if you AND those two numbers, you'll get this. Similarly for this. Can you notice something here? The number of ones, the count of the number of ones in the two numbers is 5, sorry. And the count of number of ones in the OR and AND is also 5. And the count of ones in the two numbers is 8, and the count of ones in OR and is 8. The count of ones here is 4, and the count of ones here is also 4. The count of ones here is 8, here is 8. The count of ones here is 5, and here is also 5. This is a property you should notice in this problem. Now you figure it out that instead of finding OR and you just directly find the number of ones in both two numbers, then you'll get the number of ones. Okay, they both are basically equal. So let's take this example. Let's say the array is 2, 3, 1, 1, and how many ones are there in 2? There is 1, 1 in the binary representation of 2. 2 is represented as 1, 0, 3 is represented as 1, 1, 1 is represented as 0, 1, and 1 is represented as 0, 1. So 2 has how many ones? Only 1, 1. 3 has 2 ones. 1 has 1, 1, and other one has also 1, 1. This is the count of ones. Okay. Now let's take k is equal to 3. For this one, how many numbers are there such that the sum of the ones will be greater than or equal to 3. For this one, how many numbers are there such that the sum of number of ones becomes greater than or equal to 3? There is only one number, right? And for this one, there is only one number. For this one, there is only one number. So this is the approach for solving this problem. But there is a condition that two pairs are distinct if either A is not equal to C or B is not equal to D. Okay. So now let's take an example which handles in order to understand how to handle the duplicates. Let's say the given array is 1, 1, 2 and the number of ones, the count of ones in their binary representation is 1, 1 and 1. Let's take k as 2. So this number can be valid, can form pairs with how many numbers? It can form pair with this number and this number. Why? Because their sum is greater than or equal to k. You got the point? Now, so we are basically considering this is a valid pair and this is also becoming a valid pair, which shouldn't be the case. 1 and 2 are both are same as mentioned in the question. So what are we going to do is we'll just remove the duplicates from the array in the beginning of solving the problem only, so that we don't get the duplicate pairs. So if we are given an array like this 1 1 1 2 2 2 3 3 3, we are going to simply write it as 1 2 3, because if 1 2 is a valid pair, this 1 2 is also a valid pair, this 1 2 is also a valid pair, so they are all duplicates. Then how are you going to handle this? We'll just take all ones and put them together. We'll just put them in a hash set and write it down. We now realize that we have to maintain a count array which stores the number of ones in the particular number. So how do you get the count of ones in the binary representation of a number? So look at this example. Let's take the number 14. Its binary representation is this, and let's take n minus 1, which is 13, and its binary representation is going to be 1101. Now if you perform an AND operation on these two numbers n and n minus 1, you will notice that the last set bit in the number will become 0. I hope you got the point. I am repeating it. The last set bit in the binary representation is 1, and if you perform AND with n minus 1, then the last set bit becomes 0, as you have noticed. Now let's take another example for you to understand. Let's take a number 28. Its binary representation is this, and the last set bit is this one. If you perform an AND operation with 28 minus 1, whose binary representation is this, then you will notice that the last set bit will become 0. I hope you got the point, right? So how many times should you perform this operation so that you will exhaust all ones? With one operation you are exhausting 1 1. So how many times you should perform this operation? so until n becomes 0, you have to perform this operation. Which operation? N and n minus 1. If you perform this operation until n becomes 0 and maintain a count, each time you perform this operation, 1 is gone. So if you maintain a count, and it will get you the count of set bits in a number. I'll show you the code so that things get clearer to you. So here is the code. Initially the count is 0. We are given an integer. We are performing n and n minus 1, and we are maintaining the count. This count is nothing but the number of ones that are present in an integer, in the binary representation of an integer. So this is about this method, and the problem is not yet done. So I hope you got the point that we have to maintain a count array which stores the number of ones in the binary representation of a number. Now, and how to get that count? Using that method I explained to you previously. Now watch. Now the problem reduces to, if you are given an array 1, 2, 3, 4, 5, and k, and this array is nothing but, this is not the original array, this is the count array. Let's take k is equal to 5, and how do you get the number of pairs? Number of pairs whose sum is greater than or equal to k. How do you get the number of pairs whose sum is greater than or equal to k? This is a binary search problem. You can find it on Google. If you are given an array and k, you have to find the number of pairs whose given sum is greater than or equal to k. How will you solve this problem? 1, 2, 3, 4, 5, the given array. Start from here. If you include this 1 into the sum, the remaining, how much more should we find? 5 minus 1 is 4. We need 4 more to get the sum greater than or equal to k. So what you will do is, you will binary search in the right part of the array for 4, right? Not for 4, but the first occurrence of 4. Alright, the array is sorted. You should find the first occurrence of 4 in this array. You will get an index. From this index, whichever element is after that index can form a valid pair with 1, because after that it will definitely be greater than 4. So the sum becomes greater than or equal to k. Understood the point? You will get an index from binary search of the first occurrence of the target, and then you have to find the number of elements in the array after that index, including that index, and that many pairs can be formed from the current element. Similarly, you do it for 2, and then for 3, and update the result, and lastly return the result. This is how we approach the problem. I think if we look at the code, it will be more clearer. I hope I have left no stone unturned for this problem. If we look at the code, we'll get more clarity. Firstly, we discussed about the importance of maintaining a count array. Firstly, we discussed about how to handle duplicates. We handle duplicates by adding. We don't consider the duplicate elements in the nums array. We'll simply add it to a set and add them back to the count array. No, we don't add them back. For each element in the set, we find the count of ones, the number of ones in the binary representation of each element, and store them in an array. The array is count ones. We store them in an array. And how do you find the number of ones in the binary representation of a number? This is a code. I have already explained it. And after that, we are sorting the count ones array because we have to perform a binary search. Now we traverse the count ones array, and for each element we find the target. We try to find the target using binary search. The target becomes k minus current element, and the search range is from I plus 1 to the last element. And we start the binary search. If the current element is greater than or equal to target, that possibly could be a valid index. So I'm updating the index value, and I am trying to find out the the least value which satisfies the condition. So I'm going towards left. If the current element is less than target, I'm going towards right. Finally, I'll find the index value, which is the least valid index, such that the sum becomes greater than or equal to k. Now, if I find a valid index, if index not equal to -1, I am finding the greater elements. The count of greater elements becomes this formula. This is not a formula. If you try to find the number of elements greater than that index, you will get this. I messed it up. I think I should cancel these once. So the total elements minus index will give you the greater elements. And here it is mentioned that if 1, 2 is a valid pair, 2, 1, these two pairs are distinct. They have given that these two pairs are not the same. So if I get 1, 2 as a valid pair, I am going to assume that 2, 1 will also be a valid pair because their sum is indeed the same. So I'm multiplying twice of the greater numbers so that we can handle this case. And we are given one more thing in the question, that for every element you can consider it twice. I will show you this, that here it is given that for a pair, if num1 is equal to num1 can also be excellent if you have at least one occurrence. Even if you have one occurrence of a number, you can consider it consider it and itself as a pair. I hope you got the point. So what I'm doing is, if the current element has greater than k by 2 ones, if the current element has greater than or equal to k by 2 ones, then the same thing will also greater than k by 2, the same thing will also have greater than or equal to k by 2 ones. So the total becomes greater than or equal to k, right? So if the current element satisfies this condition, it can also be formed as a pair. So I am incrementing the result, and finally I am returning the result. I hope you got the problem. I am struggling a bit in explaining things, but I promise you that I keep trying until I get optimal in my explaining skills. So this is all for this video, guys. Thank you very much. for watching this video.